The concept of using electronic anodic oxidation for corrosion protection in building materials is intriguing and aligns with the principles of using controlled electronic systems to induce protective oxidation layers on metal surfaces. This approach could potentially be applied to various construction materials to enhance their durability and resistance to moisture, rust, and corrosion. Here's a breakdown of the concept. Electronic anodic moisturizer, rust, corrosion protection by oxidation for building. 1. Electronic corrosion protection. Similar to your previous description, electronic corrosion protection involves using electrical or electronic systems to modify the electrochemical reactions that led to corrosion. The goal is to reduce or prevent the corrosion process on metal surfaces. 2. Anodic oxidation in building. In the context of building materials, anodic oxidation could be employed as a method to enhance the corrosion resistance of metals used in construction. By applying a controlled electric current to the metal surface, the metal undergoes oxidation, forming a protective oxide layer. This oxide layer acts as a barrier between the metal and the surrounding environment, reducing the likelihood of corrosion. 3. Integration of concepts. Building on the integration of concepts, the approach could involve the following steps. Electronic system design. Develop an electronic system that can apply a controlled anodic current to the metal surfaces of building materials. Potential control. The electronic system would regulate the potential voltage applied to the metal surfaces. This ensures that the metal reaches the anodic region where oxidation occurs. Oxidation formation. Applying the anodic potential induces oxidation on the metal surfaces. This leads to the creation of a protective oxide layer that enhances corrosion resistance. Corrosion protection. The oxide layer acts as a physical and chemical barrier, protecting the metal surfaces from moisture, rust, and corrosion. This layer helps extend the lifespan of the building materials. Benefits and considerations. Durability. The protective oxide layer can enhance the durability of building materials, reducing the need for frequent maintenance and replacements. Cost savings. Longer-lasting materials can result in cost savings over time due to reduced maintenance and replacement expenses. Environmental impact. Extending the lifespan of building materials aligns with sustainability goals by reducing resource consumption and waste. Research and development. Implementing such a system would require careful research, development, and testing to ensure its effectiveness and compatibility with various building materials. Integration with construction. The system's integration into the construction process and its compatibility with existing building techniques would need to be addressed.